A factory makes low-cost batteries. Unfortunately, 20% of the batteries are faulty. Batteries are sold in packets of 20. Let X be the number of faulty batteries in a packet. State the distribution of X and determine its mean and standard deviation. So I'm going to say that X is binomial. We have a fixed number of trials and we can assume a constant probability of success. In this case, success is the faulty batteries, finding a faulty battery. So the mean for a binomial is always just n times p. So the mean is going to be 20 times 0.2, which is 4. And the variance is np1 minus p, so that's going to be 20 times 0.2 times 0.8. So that's going to be 4 times 0.8, which is 3.2. And so the standard deviation of X is going to be the square root of 3.2. So square root 3.2, which is about 1.79. Correct to 2 decimal places. We now want to calculate the probability X is greater than or equal to 5, so that's a calculator job. Let's just clear everything and we can get rid of the keyboard. So interactive distribution, binomial is a discrete distribution and we're looking at a range of values here, so CDF, and we're going from 5 and up to 20 because we know there's 20 in the packet. The number of trials is the 20, that's how many batteries we have, and the probability of success is 0.2, and so that's 0.3704. A customer buys 20 packets of batteries. Let Y be the mean number of faulty batteries per packet. According to the central limit theorem, Y will be approximately normally distributed. Determine the mean and standard deviation of Y. So the mean will be the same as it was for the original binomial distribution, which is 4. The variance is going to be the original variance, which was 3.2, divided by 20, and therefore the standard deviation for Y is going to be the square root of 3.2 divided by 20. The 20 here comes from the 20 packets being bought. So we have that Y is normal for 3.2 over 20. We now want to calculate the probability that Y is greater than or equal to 4.2, so that's a calculator job. So this time we're using normal. So we're going from 4.2 upwards, so essentially we're going upwards to infinity. We need to put that in upper. Now our standard deviation is the square root of 3.2 divided by 20, and our mean was 4. So that's 0.3085. In a sample of 400 batteries, what is the probability that at least 84 will be 40. Note here, no mention of means or anything like that, so we're not using central limit. We're back to a binomial distribution. We can't use y, we've already used that. Let's use something else, such as v. So v is a binomial with 400 trials. Probability of success is still 0.2. And we want the probability that v is more than or equal to 84. So we can get that on the calculator. So discrete distribution, binomial. So we're going from 84 all the way up to 400. There are 400 trials, and this is 0.2, and that gives us 0.3272. Explain why the answer in part C, this answer, should be close to the answer in part B. We're talking about similar proportions. 4.2 out of 20 is equal to 4.2 times 20 over 20 times 20, which is equal to 84 over 400. So we're talking about similar proportions, so the answers should be similar. Explain why the answer in part C should not be exactly equal to the answer in part B2. Well, the CLT is an approximation. It's better if n is large, which it wasn't particularly here, and p is close to 0.5, which again it wasn't here. So these are the important facts.